I'm Kurt, and welcome again to Comp Sci in 5. We went over our first data structure. We introduced it. It's called a linked list, and it's formed with a collection of nodes all linked together. Now, to remind ourselves what a node is like a physical box, a virtual box inside the computer, and it holds a data item and a pointer or a reference to the next node in the chain. Alright, so when we look at the linked list, we have this node right here has a reference to this node, and this node right here has a reference to this node. So quite literally, in the computer's memory, they're all linked together. That's why it's called a linked list. Great. Now, utilizing that concept, remember linked list is linear, we're going to introduce a new concept called an array. So imagine that all of those nodes are smushed together, and now they don't have pointers to the next node, but because they're smushed together, they don't need pointers to the next node, because handy dandy, we can just index them right here. So I have a nice little array prepared for you. There's 5 spaces because it's Comp Sci in 5, and we can put in any type of data that we want in here, which I'm going to do right now. One thing to note with arrays is they're of a fixed length. Inside the boxes are the data, and we index them with these numbers. This is convenient for when you want to instantly grab a data item. You can call it by its index. Think of it like a bookmark. So if we did something like this, what would it be? Well, this is the index right here. So this would be A. Likewise, we could change this to a 1 and it would B. Change it to a 2, it would be C. So on and so forth. That's super great. What's also cool about arrays is you can change these elements by calling the index as well. So if we wanted to change it, and we wanted to change, let's say, this number, we could say array of 3 doesn't equal A anymore. It equals B, and then in the computer's memory, we would do that. So that's arrays for you. Now it's a perfect time to do a comparison between these two linear structures, right? So over here, the major thing that needs to be noted about linked lists is they're dynamic. That's the word I want you to remember, dynamic, whereas arrays are static. Arrays are static because they're of a fixed length. Because they're of a fixed length, we can index them. Therefore, we can grab a data item instantaneously, immediately. So if you're writing a program and you need to get quick access to your data elements and you don't need to add any elements, well, an array is your best bet. However, linked list, on the other hand, is a dynamic data structure, which means it's very easy to add nodes or delete nodes. All you need to do is manipulate these pointers or these references to new nodes. You can't grab an element with a linked list instantaneously because these poor nodes, they only know their node buddy that's right next to them. How could they possibly know the node buddy way over here when they only have a reference to the next node? Unlike the static structure, the array, you can grab them by element. So remember, linked list, dynamic. If your data set's going to change, use a linked list. Arrays, static. If your data set's not going to change, you want to access the element immediately, use those. Thank you. That's all the time we have. Comp Sci in 5.